Hello students, welcome to the maths class again. Today in this video I am going to explain exercise 2C. To solve the questions of this exercise, you need to know these points: inverse functions, condition of invertibility, properties of inverse functions, composition of a function and its inverse, self-inverse functions. So one by one I am going to explain these points. Try to understand. First point is inverse functions. What are inverse functions? To understand this point, you see here. Suppose we are having two functions f such that a to b and g such that b to a. What is the specialty in these two functions? You can see here, domain of second function is the range of first function and range of second function is the domain of first function. If such type of functions you are having, then you can say they are the inverses of each other. Now how it is possible? This is the question. Suppose we are having a equals 1, 2, 3. Set b equals 6, 7 and 8, and also we are having fx equals, function f is defined as fx equals x plus 5. Now domain of the function f, as you know, is a. So from a you can put the values of x and then you see what is the result. If you put x equals 1, then 1 plus 5 you are getting 6. If you put x equals 2, then f2 you are getting 2 plus 5 equals 7. If you put x equals 3, then f3 you are getting 3 plus 5 equals 8. It means that from domain you are putting the values and you are getting the values 6, 7, 8. These are the values of set b, means range of the function. Now what should be the condition? If we put these values b from set b and we can get the values of set a, which type of rule should be there? Then we should put the values from set b and we should get the values of set a. So for this, you see, if I'm taking g in such a way that gx equals x minus 5, and if I put this 6 here in place of x, 6 minus 5 equals 1, because output of x I have to take as input of g and I should get in output of g as input of x. So output of f is 6. If I put 6 here, then I will get 1, that is the input of f. Output of, in second case, output of f is 7. If I put here 7 plus, here you can see again, g x equals x minus 5. If you put 6, then it will come 6 minus 5, 1. If you put 7, then 7 minus 5, 2. If you put 8, then 8 minus 5, 3. So now you can see in this function, if I am putting output of function f 6, 7, 8, then I am getting 1, 2, 3. These are the inputs of function f. So function f and g, in this case function f and g are the inverses of each other. Function f is x plus 5, function g is x minus 5. They are the inverses of each other. So in this way it will be possible. Second point is condition of invertibility. Actually students, all the functions do not have inverses. Some functions they have the inverses. Now which are those functions? So if functions are 1, 1 on 2 functions, then they will have the inverses, otherwise they will not have the inverses. So to have the inverse, function must be 1 on 2 function or bijective function. Now next point is properties of inverse functions. So some properties are there for inverse functions, you pay attention here. First property is inverse of a bijective function is unique and bijective. So inverse of a bijective function they are saying, because bijective functions are only invertible functions, so that's why they are saying inverse of a bijective function is unique. Unique means if one bijective function is given, its inverse will be only one, not more than one. So that's why they are saying inverse of a bijective function is unique, and it is also a bijective function. Inverse will also a bijective function, means inverse will be 1 on 2 function. Next point is coming, this point, second point, if f such that a to b is a bijection and g such that b to a is inverse of f, so fog equals ib and gof equals ia, where I, a and ib are the identity functions on the set a and b. Yes, if two functions are there, f and g, and g is the inverse of f, then in this case fog will be, means composition of f and g will be fog, and gof, fog will be ib, means identity function on set b and identity function on set a. This point I will explain in next point also. This is coming, these two properties are important properties, you pay attention on these two properties. Next point is coming, composition of a function and its inverse. Yes, this is important point. One example also I will tell you. First of all, if two functions are there, f and g, and suppose they are the inverse of each other, f is the inverse of g and g is the inverse of f. In this case, if you are finding the composition of f and g, means fog and gof, so that will come fog x equals gof x equals x. If they are the inverses of each other, then it will be the condition fog x equals gof x equals x. This will be the condition. You can see this example, it is given 32 example, fx equals 2x upon 3 minus x, gx equals 3x upon x plus 2. Use composition to verify f and g are inverses of each other. So gx is given 3, gx is 3x upon x plus 2. So gof x, when you are finding gof x, then first you will put the value of fx. So value of fx you can put in gx, so you are putting here in place of x you are putting 2x upon 3 minus x, that is the value of fx, and after simplification you are getting, you can see this simplification, you are getting x. In the same way, gof x you have found, now fog x you try to find. In fog x, first you will apply g function and then f. To apply g function, value of gx is 3x upon x plus 2. This value you put in function fx. So here you are putting the value in place of x, 3x upon x plus 2, that is the value of gx. Now after simplification you can see this step and this step, you are getting x. So in both the cases composition is equal to x. X means input value, whatever you were inputting, means in the starting you were what was the input. So gof equals fog equals x, then function f and g are inverses of each other. So that was the composition of a function and its inverse. Next point is coming, self inverse function. Students, some functions are such that their inverses are the functions itself. Which type of function these are? You see, suppose fx equals 5 upon x. Fx you can say, you can take as y equals 5 upon x, then you make x subject, then it will come 5 upon y. So now you can see given function was 5 upon x, and while when we are making x as subject, then function we are getting 5 upon y. So function is same, inverse is also same. When you are finding, suppose fx is invertible function, so its inverse, this is the method to find the inverse. I will tell you once again. You make x as subject, so 5 upon y, and you can see these functions are same function, 5 upon x and 5 upon y. So such type of function, fx equals 5 upon x, or gx equals 7 minus x, one more function is there. These are the examples of self inverse function. One more example I will take. You see here for self inverse function, here you can see y equals here it is given y equals 5 upon x, x equals 5 upon y. One example is there in this 35 example. Fx equals 4x plus 3 upon 6x minus 4. X is not equal to 2 upon 3, because if x equals 2 upon 3, then denominator will be 0, and by 0 division is not possible, so it will not be a function. So show that FOF equals x. In self inverse case, FOF is equal to x, means FOF will come equal to x. What is the inverse of f? So inverse of f you have to find. So FOF x you try to find. FOF f means in function fx you put the value of x as 4x plus 3 upon 6x minus 4. You have put here, you can see. After solving you are getting 34x upon 34, and final answer is x. So value of FOF x is x. If value of the given function and its inverse is coming x, then you know f and f, composition of f and f is x. So given function is self inverse function. Next point is, so these were the points. Now some examples I am going to take. This example you take. Now how can we find the inverse of a given function? This is the question. There are two types of problems in this exercise. Some functions will be given and it will be said in the question that this function is invertible. You find only inverse. And second type of problem, in that problem you will show the function is invertible and then you will find the inverse of that function. So first type I am going to take. This in this type, f is an invertible function defined by fx equals under root 2x minus 3, then find its inverse. Already it is said it is invertible function, so its inverse exists. You have to find only. It is a unique, means fixed procedure. First of all, whatever given function is there, you suppose that function as y equals under root 2x minus 3. Then you simplify and make x as subject. After simplification, you see squaring both the sides, x equals y square plus 3 upon 2. I have made here x as subject. Now after making x as subject, in place of x you have to put f inverse y. This is also fixed step. So f inverse y equals y square plus 3 upon 2. Now replace y by x. So f inverse x equals x square plus 3 upon 2. So this is the method. You have to find inverse of the given function when it is said function is invertible. Directly you can find. Now second type of problem is coming. This question. Here, show that the function fr2r defined as fx equals 4x minus 7 is invertible and find f inverse. This time you have to show invertible and then you have to find inverse. So to show invertible, this function should be bijective function, as I told you just before. So bijective function, to show bijective function, it should be 1 1 on 2. So for 1 1 on 2, fixed step in last video I told you. Then you will take two elements from domain of f such that their images are equal, means x1 and x2. x1 and x2 be two elements of R, means from domain, such that fx1 equals fx2, means their images are equal. And after taking this, if you are getting these elements are also equal, means x1 equals x2, then function will be 1 1 function. So f1 equals x2, fx1 means 4x1 minus 7, fx2 means 4x2 minus 7. 7 is cancelled, 4 is also cancelled, then you are getting x1 equals x2. So f is 1 1. Now for on to, you have to suppose y, given function as y equals fx. So y equals 4x minus 7. Make x as subject. You have made x as subject. It is coming y plus 7 upon 4. Now you can see, for every value of y, this x is defined, means y is the range, means from range you have to take the values of y. So if you put any value of y, then value of x will come, you will get a value of x, means no value of y is there that will make the value of x not defined or imaginary, such type of value it is not making. So in every case you will get the value of x. So it is written, from the above it is seen that for every value of y there exists a pre-image x such that x belongs to real number. So f is onto. So now you have shown f is 1 1 as well as onto, so f is a invertible. Now to find its inverse, as I told you, you make as x as subject. So already you have made here, you can see. So in place of x, now you put f inverse y, as I told you in previous example, and then after that you can replace y by x. So this is the inverse of the given function. So like this, two types of problems you will find in this exercise second C. And after getting this video, you will be able to solve all the questions of this exercise. If you have any doubt, so you can ask, you can write in the comment, you can ask through comments, and I will reply there. So students, solve the question of this exercise. I hope you have understood all the concepts of this video. So thank you and have a good day.